So as promised, I'm going to finish up by graphing lots of parabolas. I'm going to start by just kind of summarizing the strategy we're going to use to find solutions so we can plot our points and get a graph. And then I'm going to work lots of examples. So let's start with a general strategy. So we have our quadratic equation in two variables. And the solution set to a quadratic equation in two variables graphs to a parabola. If the leading coefficient a is greater than 0, then the parabola opens up. And if the leading coefficient a is less than 0, then the parabola opens down. The vertical intercept of the parabola is the point 0c. Now this is something Steve and Candace didn't talk about explicitly, although it did come up in some of the examples they worked. When we're talking about the vertical intercept, the first coordinate, in this case x, is 0. We need to figure out the second coordinate. Well, if we plug x equals 0 into our equation, we have y equals 0 plus 0 plus c. So the second coordinate, the y coordinate of the vertical intercept, is c. So it's very easy to determine the vertical intercept. We're just going to look at the constant term in our quadratic equation. What about the horizontal intercepts? Well, we find the horizontal intercepts by setting y equal to 0 and solving for x. We'll be solving a quadratic equation in one variable. The first coordinate of the vertex can be determined using the formula h equals the opposite of b over 2a. I'm calling the vertex the point hk, and you'll see that in a picture in just a minute. The second coordinate of the vertex, which I'm calling k, we could find just by dropping in h, the value of h, into our formula. That will give us the corresponding y value. The line x equals the opposite of b over 2a is the axis of symmetry. And I can often use this symmetry to find some other solutions to the equation quite quickly. We'll see examples of this. So let's put this all together. Here's a parabola. In this case, our parabola opens up, so we know that the leading coefficient is positive. The vertical intercept will be at the point 0c, where c is the constant term in our equation. The x-intercepts can be found by solving a quadratic equation. We don't have to use the quadratic formula to solve that quadratic equation, but it will always give us the x-coordinates of the horizontal intercepts. The vertex, which I'm calling the point hk, can be determined. We can find h, the x-coordinate of the vertex, using Steve's formula, the opposite of b over 2a, and then we just find k by plugging that value of x into our equation. So now I'm going to work some examples. I'm just going to go through the types of questions, the things I write down on my paper when I'm graphing a parabola by hand. Sometimes these get a little messy. We've got to find a lot of solutions to get a good graph. So you have to be kind of patient and careful when you're graphing parabolas. So first of all, does the parabola open up or down? Well, in this case, the parabola opens down. How do I know that? Well, I'm looking at the coefficient on x squared. And in this case, that coefficient is -1. So a is negative, the parabola will open down. What about the vertical intercept? Well, I look at the constant term. That's 16. And that's going to give me my y-coordinate of the vertical intercept. That was easy. How about the horizontal intercepts? I have to work a little bit harder to find the horizontal intercepts. I'm going to need to solve the equation 0 equals 16 minus x squared. I'm setting y equals 0 and solving for x. Adding x squared to both sides, I get x squared equals 16. And using the square root property, I get x equals plus or minus the square root of 16, which is plus or minus 4. So this particular parabola has two horizontal intercepts, one at -4, 0, and one at 4, 0. How about the vertex? Well, I need to find both the first and second coordinate. Using my formula for the first coordinate, h equals the opposite of b over 2a. b is the coefficient of the linear term. In this case, b is 0. a is -1. And actually, it doesn't matter what a is because we see that the first coordinate of the vertex is going to be 0. Well, if x equals 0, y equals 16, and we've seen this point before. This is also the vertical intercept. So the vertex and vertical intercept are the same point. So we have the vertex, we have the x-intercepts. We want a few other solutions so that we can graph this parabola. So the first thing I'm going to do is kind of set up a scale on my axes so that I can see the points I'm interested in. My vertical intercept is at 0, 16, so my y-axis is going to have to show 16. My x-intercepts are symmetric around the y-axis, so I want to make sure that I see these points on the x-axis. So when I set up my graph paper, I'm going to put my horizontal axis kind of down near the bottom of my graph paper. And my y-axis just kind of right in the middle. Now I want to choose an appropriate scale. So I'm going to use a scale of 1 on the x-axis. And since I have to go to 16 on the y-axis, I think I'll use a scale of 2 on the vertical axis. So I have 4, 6, 8, 10, 12, 14, 16, 18, 20. So let's plot the solutions I know. 0, 16 is a solution. That's the vertex and the vertical intercept. And I have 2 horizontal intercepts at -4, 0 and at 4, 0. Now I need some other solutions to get a good parabola. So let's ask ourselves, what happens when x equals 1? Well, when x equals 1, y equals 16 minus 1, which is 15. So I know the point 1, 15 is on the parabola. Using symmetry, I also know that the point -1, 15 is on the parabola. How about when x equals 2? Then y equals 16 minus 2 squared, 16 minus 4, which is 12. So 2, 12 is on my parabola, and using symmetry, -2, 12 is also on the parabola. How about when x equals 3? Then y equals 16 minus 3 squared, 16 minus 9 is 7. So the point 3, 7 is on the parabola. Using symmetry, the point -3, 7 should also be on the parabola. Finally, let's see what happens when x equals 5. If x equals 5, then we have y equals 16 minus 25. That would be y equals -9. Well, if I look at my scale, I see I cannot plot the point 5, -9. So I know that the parabola is going to go off the graph somewhere between x equals 4 and x equals 5. So putting this all together, I get a parabola. Let's do another example. In this case, the parabola opens up. A is 3. The vertical intercept, that's easy. This is the ordered pair 0, 5. You need to remember that it's easy to find the vertical intercept, but we have to work for the horizontal intercepts because we have to solve a quadratic equation. When we set y equal to 0, we end up with a quadratic equation. So now I want to solve this, and I'm going to use the quadratic formula here. So I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to simplify this a little bit. I have negative 6 plus or minus the square root. Let's look at the expression under the radical. I have 36 minus 60. 36 minus 60 is negative 24. So when I have a negative under the radical, what this means is I have a situation where I have no horizontal intercepts. How about a vertex? So I'm calling the vertex HK, and I need to find both coordinates of the vertex. Well, the first coordinate of the vertex is given by the formula opposite of b over 2a. In this case, that would be the opposite of 6 over 2 times a, which is 3. This is negative 1. The first coordinate of the vertex is negative 1. What about the second coordinate? Well, I'm going to find that by evaluating my formula for x equals negative 1. So 3 times negative 1 squared plus 6 times negative 1 plus 5. That's 3 minus 6 plus 5. That is 2. So I have negative 1, 2 as my vertex. So I have some solutions that I can graph. I know the vertex and I know the y-intercept. So when I'm thinking about graphing this, I know my vertex lives in the second quadrant. My y-intercept is above the x-axis. Parabola opens up, so it's going to be living kind of going up from the second quadrant. So I'm going to put my horizontal axis kind of down near the bottom of the page. And my vertical axis kind of in the middle, but maybe a little bit off to the right, because I know the vertex lives in the second quadrant. So now I want to scale. My vertex is at negative 1, 2. In order to prevent things from being too squished near the vertical axis, I think I'm going to use a scale of 1/2 on my horizontal axis. And on my vertical axis, I think I'll just use a scale of 1. So let's plot the only two solutions I have so far. The vertex is at negative 1, 2, and the y-intercept is at 0, 5. So now I need some other solutions. Well, I can get another solution quickly using symmetry. The y-intercept is 1 unit away from the vertex. So if I move 1 unit to the left, I get another solution, negative 2, 5. Let me find some other solutions. So for example, what happens when x equals 1? Well, plugging this into my equation, I have 3 plus 6, that's 9, plus 5 is 14. So the point 1, 14 is on the graph. Well, 1, 14 is going to kind of go off the grid here. Same thing is going to be true at negative 3. How about if x is 1/2? Well, here I'm probably going to have to write out a computation. If x is 1/2, then y equals 3 times 1/2 squared plus 6 times 1/2 plus 5. So that's 3/4 plus 3 plus 5. So that's 8 3/4. I'm just going to write that as a decimal, and that will be on my grid. So I'm going to have the point 1/2, 8 3/4, which is right about here. So there's going to be a symmetric point that will be 1, 2, 3 halves away from my axis of symmetry. So 1, 2, 3 halves away from my axis of symmetry gives me another point. So putting this all together, I get get a pretty decent sketch of my parabola. Let's try another example. Now we have y equals 1/2 t squared plus t minus 12. This parabola will open up. In this case, a is a number less than 1, but it's still greater than 0, so the parabola opens up. Vertical intercept, this is going to be the point 0, -12. How about the horizontal intercepts? In this case, there'll be t-intercepts, and I'm going to have to solve a quadratic equation to find these t-intercepts. So I'm going to solve the equation 1/2 t squared plus t minus 12 equals 0. I think I'm going to multiply both sides of this equation by 2 to clear that fraction. So I have t squared plus 2t minus 24 equals 0. Are there integer factors of -24 that add to 2? Yeah, +6, -4. So this will factor quite easily, and I get two possible solutions here, t equals 4 or t equals -6. So I have two horizontal intercepts at -6, 0 and at 4, 0. So I'm doing lots of scratch work before I start graphing this parabola. How about the vertex? Well, I'm going to call the vertex HK again. And to find H, that's going to be the opposite of B over 2A. So in this case, B is 1, A is 1/2. So this is the opposite of 1 over 2 times 1/2. Well, 2 times 1/2 is 1. The opposite of 1 over 1, that's just -1. So if my t-coordinate of the vertex is -1, I need to find my y-coordinate of the vertex, which I'm calling k. So this is 1/2 times the square of -1 plus -1 minus 12. So this is going to be 1/2 minus 13, so this is -12.5. I'll write that as a decimal. So now I have the coordinates of the vertex. So I have a bunch of solutions here, but before I start graphing, I want to think about the scale. Look at the y-coordinate of my vertex. It's -12.5. Look at my y-intercept. It's -12. So when I draw my y-axis and my horizontal axis, I want to make sure I can see -12 and -12.5 on the vertical axis. Look at the t-intercepts. They live on both sides of the y-axis. So I want to put my y-axis somewhere near the middle. So when I'm setting up my axis system, I'm going to put my horizontal axis kind of up near the top here. And in this case, my horizontal axis is my t-axis. I'm going to put my vertical axis more or less in the middle. And in this case, this is my y-axis. Now I want to choose a scale. I think I'm going to choose a scale of 1 on the t-axis. And I think I'm going to choose a scale of 2 on the vertical axis. So this is -4, -8, -12, -16. Here's 4, here's 8. So let's plot the solutions I know. I have the vertex at -1, -12.5. Now notice I only went a quarter of a way between this tick mark and the next one. That's because I have a scale of 2. Halfway between would be -13. So -12.5, I just went about a quarter of the way down. 0, -12, that's my vertical intercept. I have two horizontal intercepts at 4, 0 and -6, 0. Now I can use symmetry to get the point -2, -12 on my parabola. But I want some other solutions. So let's ask, well, what will happen when t equals 1? So if t equals 1, then y equals 1/2 plus 1 minus 12, which is, let's see, negative 11 plus 1/2. That is negative 10.5. So I have the point 1, negative 10.5. So let's plot that point. 1, negative 10.5. Well, using symmetry, I am 2 units away from my axis of symmetry. So if I go 2 units to the left, I get another point. Let's see what happens if t equals 2. If t equals 2, then y equals 1/2 times 2 squared plus 2 minus 12. So 1/2 of 2 squared, that's 1/2 of 4. That's 2 plus 2 minus 12, which is negative 8. So I have the point 2, negative 8 on my parabola. So 2, negative 8 is right here. So using symmetry, I'm also going to have a point 3 units to the left of the axis of symmetry with a y-coordinate of negative 8. How about if t is 3? Well, let me just do my calculation up here. If t equals 3, then y equals 1/2 of 9, that's going to be 9/2, plus 3 minus 12. So I have negative 9 plus 9/2. That will be negative 4.5. So I'm going to have the ordered pair 3, negative 4.5. Kind of messy. 3, negative 4.5. But using symmetry, I easily get another point. I am 1, 2, 3, 4 units away from the axis of symmetry. So going 4 units to the left, I get another point. Last thing I really have to check is what happens when t equals 5. So let's see if I can do this arithmetic in my head. I have 1/2 of 25, that's 12.5, plus 5, so that's 17.5, minus 12, that is 5.5. So I'm going to have the point 5, 5.5. That is right about, this is 6, so here's about 5.5. Using symmetry, I'm also going to have a point at negative 7, 5.5. I've got lots of points on my parabola. Putting it all together, drawing a nice smooth curve through all of these points. Wow, that almost looks symmetrical. So let's do another example. So does this parabola open up or down? Well, this particular parabola will open down. How do I know that? Well, the leading coefficient, a, is negative. What about the vertical intercept? Well, this is the easiest question I ask myself. That's going to occur at the point 0, negative 4. Horizontal intercept. I'm going to have to work. Now what I notice here is my leading coefficient is negative 0.25. That's the same as 1/4. So I think I'm going to write my quadratic equation as negative 1/4 x squared plus 2x minus 4 equals 0. You may wonder why I did that. Well, now I can multiply both sides of the equation by negative 4 to clear that fraction. Now I'm multiplying both sides by negative 4. Perhaps I should write this out just to make it clear. So that's going to change some signs on the left side of the equation. I end up with x squared minus 8x plus 16 equals 0. But I'm noticing a perfect square trinomial on the left side. This factors as x minus 4 quantity squared. So this equation has only one solution, x equals 4. That means my horizontal intercept, there's just one of them, and it's the point 4, 0. Well, the next question is, what is the vertex? Well, when we have just one horizontal intercept, the vertex is that horizontal intercept. But let's just check Steve's formula. Let's calculate the first coordinate of the vertex using the formula the opposite of b over 2a. Well, that's going to be -2 over 2 times, and I'm going to write that decimal as a fraction. That's -1/4. So I have -2 divided by -1/2, and that is 2. -2 times the reciprocal of -1/2, which is +4. Now when I plug 4 into my equation, so I have -0.25 times 4 squared plus 2 times 4 minus 4, 1/4 of 16, that's -4 plus 8 minus 4, which is indeed 0. So the vertex is indeed the horizontal intercept. So now we have two solutions to our quadratic equation. So before we find some other solutions, let's kind of think about how we're going to set up our coordinate axes in this case. Well, my vertex is at 4, 0. That lives on the positive x-axis, kind of over on the right side of my graph paper. The y-intercept lives below the x-axis. So when I draw my axes, I think I'm going to want my horizontal axis kind of high up on the paper. And I want my vertical axis over to the left. I think I'm just going to choose a scale of 1 on both axes in this case. So +2, -2, -4, -6, -8 on the vertical axis, and 2, 4, 6, 8, -2 on the horizontal axis. So here is my vertex. Here is my vertical intercept, my y-intercept. Remember, the parabola opens down, so everything's okay here. Using symmetry, I know that 8, -4 is also on the graph of the parabola. But let's find some other solutions. So let's ask what happens when x equals 2, for example. So when x equals 2, 2 squared is 4. -1/4 times 4, that's -1. So I have -1 plus 4, that's 3. 3 minus 4 is -1. So the point 2, -1 will be on this parabola. So now, using symmetry, I am 2 units away from the axis of symmetry. Moving 2 units away to the right gives me the point 6, -1, which should also be a solution to this quadratic equation. You can check that. What happens when x equals 5? Well, here I have quite a calculation to do. I have to calculate y equals -0.25 times 5 squared plus 2 times 5 minus 4. I'm going to just pull out a calculator to quickly get a y coordinate here. So I have 0.25, make it negative, times 5 squared plus 2 times 5 minus 4. That's going to be -1/4. So the point 5, -1/4, is on the graph. Using symmetry, 3, -1/4 should also be on the graph. How about if x equals 1? If x equals 1, I have 1 times -1/4 plus 2 minus 4. So I have 2 minus 4, that's -2 minus 1/4. So that's going to be -2 1/4. So 1, -2 1/4 is on the graph. Using symmetry, 7, negative 2 1/4 should be on the graph as well. Let me check to see what's happening when x equals negative 1. Well, when x equals negative 1, I have y equals negative 0.25 minus 2 minus 4. That's going to be negative 6.25. So negative 1, negative 6.25. Using symmetry, there's going to be also a point at 9, negative 6.25. Let's just do one last check and figure out what's going to happen when x equals negative 2. Then I'm going to do my calculation up here at the top. Then y is going to equal negative 0.25 times negative 2 squared plus 2 times negative 2 minus 4. So I have negative 1/4 of 4, so that's negative 1, minus 4 is negative 9. Kind of messy finding all of these solutions. Negative 2, negative 9 is on the graph of the parabola, but that's going to be kind of right off my grid down here. So I think I have enough points to get a fairly good sketch of this parabola. One last example. This parabola opens up. That's an easy question. Now, one of the reasons why we keep asking this question is when you start plotting solutions, if you've made a mistake in a calculation, which might happen, sometimes knowing whether the parabola opens up or down and knowing about the symmetry can indicate that a mistake has been made. So you want to keep this in mind as you start plotting solutions to this equation. Vertical intercept, 0, negative 1. We like that point because it's easy to find. How about the horizontal intercepts? Well, now I have to solve the quadratic equation 2x squared plus 2x minus 1 equals 0. I know there are no integer factors of negative 2 that add to 2, so I'm going to have to pull out the quadratic formula. So I have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying this a little bit, I have negative 2 plus or minus the square root of 4 plus 8, which is 12, all over 4. I'm going to get irrational numbers for the x-coordinate of the horizontal intercepts. So the best I'm going to be able to do is kind of estimate where they are in my graph. But I definitely want a decimal approximation of these solutions to help me get a sense of where to plot them. So I've already calculated these, and we'll see those on our screen of our solutions. What about the vertex? So h equals the opposite of b over 2a, which in this case is negative 2, over 2 times 2, which is negative 1/2. So when h is negative 1/2, then k is 2 times the square of 1/2, negative 1/2, plus 2 times negative 1/2 minus 1, which is 1/2 minus 1 minus 1, which is 1/2 minus 2, which is negative 3/2. So here are the points we found. We have our vertex, we have our approximations for where the x-intercepts lie, and our y-intercept. I'm going to start by setting up my coordinate plane and establishing a scale. Looking at the coordinates of the vertex, I think a scale of 1/2 on both axes is going to be pretty good. So I'm going to put the origin about in the center of my paper. Using a scale of 1/2, going to plot the points I have. So I have -1/2, -1.5, 0, -1 is my vertical intercept, and about -1.37 and about +0.37 are my horizontal intercepts. Now I'm going to need to do a bunch of calculations to find a few more points. And I'm going to do that off camera, then we'll come back and plot all the points and graph the parabola. So finding some other solutions, using symmetry, we get a graph of this parabola. So that ends this lesson on graphing parabolas.